So in this video, we are going to discuss legendary symbol. So what is legendary symbol? If P is an odd prime and A is any integer such that GCD of A and P is equal to 1, then the legendary symbol of A by P is defined as it is equal to 1 if A is a quadratic residue mod P, and it is equal to -1 if A is a quadratic non-residue modulo P. That means legendary symbol has only two values, 1 or -1. But first we must know about what is quadratic residue modulo P. Otherwise we cannot find the value of legendary symbol if we don't know about the quadratic residue. So what is quadratic residue? If P is a prime number and A is any integer co-prime to P, that means the GCD of A and P is equal to 1, then A is called a quadratic residue mod P if and only if it is linear congruent, that is x square is congruent to A mod P as a solution. Otherwise, A is called quadratic non-residue mod. For example, we need to find the value of the legendary symbol of 3 divided by 50. According to the definition of the legendary symbol, is either is equal to 1 or -1. When it is equal to 1, if x square is congruent to 13 modulo 3 modulo 13 has a solution, has a solution, has a solution. And if it is not, if x square is congruent to 3 mod 13 has not a solution. That means if this case is not possible, then it is equal to -1. So we can check x square is congruent to 3 mod 13 as a solution or not. So for any value we can see it has not a solution. That means it has not a solution. No. It has a solution, and the solution is x is equal to 4. Yeah, x is equal to 4. If you put x is equal to 4, so 4 square is congruent to 13 modulo 3 modulo 13. Because 4 square is equal to 16, and 16 is congruent to 3 mod 13. Right? That means 13 divides 16 minus 3. 16 minus 3 is 13. So that means the value of the legendary symbol of 3 by 13 is equal to 1 because this congruence has a solution. Otherwise the value of this the value is equal to -1, right? So I think it is clear. Now we are going to discuss some properties of legendary symbol. There is a theorem. If P is an odd prime, right? So P is an odd prime means P is a prime number, but P is not equal to 2. And A and B are any two integers such that the GCD of A and P is equal to 1 and GCD of B and P is equal to 1. That means both the numbers are co-prime with P. Then the following properties are true. Number 1. First property is A is congruent to B mod P, then implies that, or what we can say, implies that the Legendre symbol of A by P is equal to Legendre symbol of B by P. Second property is A square P is always equal to 1. The third property is A by P, the Legendre symbol of A B by P is equal to Legendre symbol of A by P into B by. The fourth one is Legendre symbol of A1 by P is equal to 1, minus 1 by P is equal to minus 1 to the whole power P minus 1 divided by, is not a Legendre, the bracket, normal bracket. And fifth and the last one is AB square by P is equal to the Legendre symbol of A by P. Let's see its proof one by one. So the first one is, if A is congruent to B mod P, then the Legendre symbol of A by P is equal to B by P. So it is given that, number one, the proof of one. It is given that A is congruent to B mod P, and by the symmetry property of congruence, this is both are implies each other, that A B is congruent to A mod P. It's a symmetry property of linear congruence. This implies x square is congruent to B mod P, and x square is congruent to A mod P have the same solution. That means, because A is congruent to B mod P implies that B is congruent to A mod B is congruent to A mod P, means x square is congruent to P mod P, because in place of x we can put this, the first one. So this will be the solution for this, and this will be the solution. That means have the same solution. This implies x square is congruent to B mod P, and x square is congruent to A mod P. Either both solvable. Means if means have a solution means solvable, or both are not, both are not solvable, both are not solvable. So this implies in both the case we can see A Legendre symbol of A by P is equal to Legendre symbol of B by P. If both are solvable, if any one of them is solvable, it will give you 1, otherwise it will give you minus. In both the case they have the same value. The proof is very easy. The second one is, second, if x square is congruent to A square mod P, all, since it is always true, x square is congruent to A square, x square is congruent to A square mod P, always has a solution, always has a solution, right? Because if you put x is equal to A, so A square is always congruent to A square mod P, because A. P always divide A square minus A square. That is P divides 0. So x square is congruent to A square mod P always as a solution. This implies A square by P, Legendre symbol of A square P is equal to 1. The proof of third is what is the third property? A AB by P. AB by P is equal to A by P into B by P. Okay, right. AB by P, the Legendre symbol of AB by P is equal to A by P into B by P. Since it is given that A and P is equal to 1 and P is an odd prime. Actually, I am going to use previous result. Previous result in the last lecture, I have proved a theorem. Right? And what is that? Since if the GCD of A and P is equal to 1 and P is an odd prime, then either A to the power P minus 1 divided by 2 is congruent to 1 modulo P, right? Or A to the power P minus 1 divided by 2 is congruent to minus 1 modulo P. This is a theorem. In the last lecture, we have already discussed and proved this theorem. I will give you the link of the last lecture in the description box, so you can check the proof of this. So the theorem is this, right? But by the symmetric property, so what is symmetric property? A is congruent to B modulo P implies that B is congruent to A modulo P. Actually, they implies each other. Right? So Legendre symbol of AB by P, it is clear that either it is equal to 1 or it is equal to minus 1. In both the cases, in both the case, it is equal to A to the power AB to the power B P minus 1 by 2 modulo P. Why? Because it is equal to 1 or minus 1. That means from this equation we can write 1 is congruent to A to the power P minus 1 mod 2 divided by 2 mod P, and minus 1 is congruent to A to the power P minus 1 divided by 2 mod P. That means 1 is equal to this and minus 1 is also equal to this. That means the value of the Legendre symbols A by P divided by P is equal to 1 or minus 1. 1 is also 1 is equal to AB to the power P minus 1 divided by 2 mod P, and minus 1 will give you the same. That means in both the cases we have AB by P is equal to AB to the power P minus 1 divided by 2 mod P. So we can write A to the power P minus 1 divided by 2 mod P into B to the power P minus 1 divided by 2 mod P. And this is nothing but A Legendre symbol of A by P into the Legendre symbol of P by P. So the proof is very easy, but we must know the result of this theorem. What is that? If the GCD of A and P is equal to 1, where P is an odd prime, then it will give you either a to the power p minus 1 by 2 is equal to 1 mod p, congruent to 1 mod p, or a to the power p minus 1 by 2 is congruent to minus 1 mod p. By the symmetric property, we can write 1 is equal to a to the power p minus 1 divided by 2 mod p, and minus will give you the same value. And we know that the Legendre symbol of a by p or ab by p will give you 1, either 1 or minus 1, but by the previous result we can say it is in both the cases we have the same value, ab to the power p minus 1 by 2 mod p. So it is very easy to prove this property. And the next property is, and the fourth one, Legendre symbol of 1 by p is equal to 1. Okay. So by the definition of the Legendre symbol, that is x square is congruent to 1 mod p has a solution. Yeah, it always has a solution. It always has a solution. And what is that? X is equal to 1. It is a trivial solution. So if you put x is equal to 1, so 1 square is equal to 1 mod p, congruent to 1 mod. Right? That means p divides 1 minus 1. This is nothing but p divides 0, and it is always true. That means if x square is congruent to 1 mod p, so it is always solvable. Means the value of the Legendre symbol of 1 by p is always 1. Next one is Legendre symbol of minus 1 by. Right? So Legendre symbol of minus 1 by p, it is clear that it is either 1 or minus 1. Similarly, minus 1 to the power p minus 1 by 2, it is always either 1 or minus 1. That means both will give you either 1 or minus 1. That means if it is equal to minus 1 to a p minus 1 by 2, will give you either 1 or minus 1. That means they are equal. This implies we can write minus 1 to the power p is nothing but equal to minus 1 to the power p minus 1 divided by. So this is the result of, this is a proof of the second part of the fourth property. And the fifth property. Fifth property is very easy. And the last one is this. AB square by P. Legendre symbol of AB square by P. We can use the property, yeah, this one. Property number 2 into, yeah, so 3, third property. By the third property, we can write Legendre symbol of A by P into B by P into B by P. Right? That means we can write A by P into B by P square. So A by P, it is either equal to 1 or minus 1. Similarly, it is either equal to 1 or minus 1. So, but minus 1 square is again 1. That means it will give you always 1. It will give you 1 always. That means it's nothing but A by P into 1. Right? Because it is a square. It will give you minus 1 or 1. Square of minus 1 is again 1. That means this is equal to, that is, this is the proof of the fifth part. I think we have proved all the 5 properties of Legendre symbol. So it is very important. That's all. Okay. Thank you very much.